Hey there, year eights. By this point, you have now started chapter 4 and you are on measurements at the beginning of measurements in the planner. So well done for getting here and then watching the video because likely I am not here. So what is exercise 4C about? It is learning or at least revising the area of basic shapes. So you got 4 shapes here that you need to be able to tell the difference, and I want you to mark in some notations for them. Okay, so a square, notice that they have these dashes, these lines here. That's to let people know that they are equal sides. So they're saying if this is a length of L, then this must be L, this must be L, and this must be L. So all the sides have to be the same in a square, and it also has to be 90 degrees with each other, which we use a little square on the corner to indicate it is right angle. Okay, now the formula for it is length times the other side, which is length again. Sometimes they call it length squared or L squared. Okay, so write that down. That's the formula to find a square. You just times the 2 sides together. And then similarly with rectangle, I want you to put in the symbols here. So there's 1 dash, these 2 sides are the same, but these 2 sides, the opposite sides are the same, but these 2 are different. Okay, so that's why you have to use a different dash. So put in the dashes and then don't forget right angled for rectangles as well. Okay, so they're all right angled. There you go. So you got a rectangle, and we know the area of a rectangle is length times width. Okay, so that's already filled for you. Parallelogram, I like to think of it as like it's a rectangle, but skewed. It kind of tilts to a side a bit. So that means these 2 sides, opposite sides are the same. These top and bottom are the same. So I'm using the dashes, but there's also one more key notation you need to put in, that they have 2 pairs of parallel lines. So this is parallel with this, and then this is parallel. So I use 2 arrows to say that those 2 are parallel. Okay, so they're parallel going up and they're parallel going sideways. Okay, so there's 2 pairs of parallel lines there. That's what a parallelogram is, and also it can't be 90 degrees. Okay, so not 90 degrees in between. Now, how do you find the area? The area of a parallelogram is base, whatever the base is. So this length here, this base. So base multiplied to the height. It has to be a vertical height, okay? Not a slant, it has to be the vertical height. So vertical height times the height. Base times height will give you the area of a parallelogram. And then lastly, a triangle. Well, it says half base. So base is down here. That's your base, and your height is the vertical. It has to be vertical. It has to be perpendicular with the line. Kind of similar to the parallelogram as well. They need to be perpendicular with each other. So it cuts down. That is the height. Okay, so base times height, and then you halve it. That will give you the area of a triangle. Now, normally in class, depending on how fast we go, I will then explain why these formulas work. But given that I want to keep this video short, you're just going to memorize those facts. Okay? Now, on to the problems. Oh, actually, there's a few more to fill out before we do the problems. Let's do some problems first, and then we'll go to conversions. Okay. Here's some problems as an example, which I think is on this page over here. You have to first identify what shape. Well, clearly the first one, A, that's on the other side of your sheet. That's a rectangle. Okay. The area of a rectangle is length times width. Okay, and the length is usually the longer side, so that's 7. Times width is the shorter side, which is 3. So that gives you 21. But don't just write 21. I want to see you write area units, which is squared centimeters. That's the proper way of saying it. Don't say centimeter squared. That doesn't make sense. It's squared centimeters. Okay. And then same thing with this one. What shape is this? Hopefully you can identify. There's 2 pairs of parallel lines. It is a parallelogram. Okay. So a parallelogram says it's base times height. The base, we can call it 10, times height, which is perpendicular to it, which is 4. So together, that's 40 squared meters. Not meters squared, it's squared meters. Okay, the next shape, what shape is that? It is a triangle, and if you forget, you can always go back to your notes to look at the formula. And so you can see it's half base times, yes, that's right, it should be height. And so here, base could be this one. So it's half times base, which is 8, times height, which is 5. But half of 8 we know is 4, and 4 times 5, which we know is 20. 20 squared meters is the answer. So you can see that it's all about identifying the shape and then using the correct formula for each one. Now D is a problem-solving one, so this is not particularly any particular shape that you are familiar with, so it's looking like this. That's the shape. But we can find the area, okay, by doing a bit of problem-solving. So this is called a composite shape, okay, composite. This is called a composite shape. And what we can see is that, well, to get the area I want, what I could do is I can find the area of the entire thing first, okay? And that's a rectangle because you've got a length of 10 and then you've got a width of 8, true? So I can take the rectangle and then I minus this area that I don't want. If I chop this part out, then I get what I want, true? And that shape there is a triangle. So by problem solving, if I can find the area of the rectangle, which is an entire yellow region, and then you minus the triangle, which is the red region, you get whatever you want left over. So area of a rectangle, which we know is length times width. So length times width, that's for the rectangle. Minusing the area of a triangle, which is half times base times height, right? So here we're going to put it all together. We say, well, length is equal to 10 times width, which is 8. Minus half times base, which is, so this is your base. So look at your triangle, tilt your head. This is your base. We know that's 10 meters. And the height, if you look at it carefully, the height is clearly 3. So half times 10 times 3. That gives you the area of a triangle. This is the area of a rectangle. So the area of a rectangle should give me a total of 10 times 8 is 80. Minus half of 10 is 5, and 5 times 3 is 15. So in total, 18 take away 15, so 80 take away 15 is, what is that? That's 65 squared meters. So that's a problem-solving question there. So you have to think of it as like, get the entire area minus what you don't want, and then you're left with what you want, okay? So that's what you're doing. Part of the exercise is to do that. And the last part of your notes is called conversion. So if you flip back to the front page, here we go. These are some conversions I want you to write down. When you're converting meters to centimeters, we know that 1 meter is equivalent to 100 centimeters. So that means you have to times it by 100 because one of these meters you have to times by 100. But notice that there's these squares on it because that's area units. So this is called an area unit. So when you're converting area, because it's squared, you also have to square the 100. So you're timesing it by 100 squared. Centimeters to millimeters, you normally times by 10, but because it's area units, it's 10 squared. Same thing when you're dividing. You divide from millimeters to centimeters, you would have to divide it by 10, but since it's area units, you have to do 10 squared. So copy these notes down. It's divided by 100 squared. This one is divided by 1,000 squared. This is times by 1,000 squared. Okay? And then over here, just to visually give you the idea of what 1 squared meter looks like, if you think of your a room, right? If you think of 1 meter, if you went 1 meter up and then 1 meter around, the area that you're seeing there is called 1 squared meter. That's how big 1 square meter is, okay? So that's 1 meter by 1 meter. Now, there is one special conversion that we don't always use, but it does get listed in, say, realestate.com. 1 hectare, okay, so HA is for hectare, to square meters, it is equivalent to 10,000 square meters. 10,000 square meters. So think of the 1 square meter that you were picturing just now. Imagine you had 10,000 of them. That's equivalent to 1 hectare. That's how big 1 hectare is, okay? So if you want to go from square meters back to hectare, you divide it by 10,000. Okay, so just copy those notes down and a visual idea of what 1 hectare looks like. You literally then have 100 meters. Is it 100? Well, let me just think for a moment. Yes, it is. Think of a 100-meter sprint. Imagine you had to sprint 100 meters one way and then 100 meters down. That square that you get is 1 hectare. That's how big 1 hectare is. Okay, so just picture that when you're running 100 meters by 100 meters. And the reason why I know this is because 100 times 100 is 10,000 square meters. The area is 10,000. Okay, so that's why it's 100 meter by 100 meter. That's how big it is. And there we go. Let's do some conversion. So using the chart that I've given to you, this is the last example for this video. So here we go. Let's say I want to convert 3.51 squared meters. So this is the area, okay? 3.51 squared meters to squared centimeters. Looking at the chart again, let's look at the chart. Can you see going from squared meters to squared centimeters, it's times by 100 squared. So on your calculator, I want you to type in, well, what is 3.51 times 100 squared? Okay, so here we go. I'm going to pop out my calculator. And 3.51 times 100 squared. And that equals to 35,100. Okay, so 35,100 squared centimeters. Now, if you have a calculator where you can't put the square, then you can do 3.51 times 100 and then times 100 again, because 100 times 100 is what 100 squared means. Okay, and you should still get the same answer. Okay, so that should still work. But there you go. And if you didn't have a calculator, you can understand it as this. 100 squared is 100 times 100, yeah? So you just count the number zeros. So 1 times 1 is 1, and then there's 4 zeros there. So 1, 2, 3, 4. There you go, it's 10,000. But then when you say, what is 3.51 times 10,000? Well, one of the tricks you might have learned in primary school or year 7 is that there's 4 zeros. You can move the decimal 4 places forward. So it's 1, 2, 3, 4. And then you fill in the empty spots with a 0. And that gives you 35100, which is exactly what we got here. So I'm showing you a couple of ways there, but please use a calculator. Unless your arithmetic skills are pretty good, then what I just described will make sense to you. Okay? And the other one is, well, what if you want to convert squared millimeters to squared centimeters? And hopefully if you look at your chart, it is divide by 10 squared. Okay? So to divide by 10 squared, that is on your calculator, 150 divided by 10 squared. And that gives me 1.5. And so the answer is 1.5 squared centimeters. There you go. That's it for today's lesson. So you've got formulas for the area of basic shapes, and you've also got unit conversions where hectares is generally not always used, but in this exercise, you'll find maybe 1 or 2. Okay? And in terms of areas, maybe the problem-solving one could be a bit tricky for some people, but that's where you'll practice. Okay?